So you've been introduced to for loops, but it can be hard to get your head around them because we're learning how to think in code. But how are we going to think in code if we can't really see the computer thinking out loud? So I'm going to show you some code, introduce you again to for loops, and then I'm going to provide you with a tool that you can use to watch code execution in action. Where we're going to start is I'll just come up with a function that uses a for loop to sum a bunch of numbers. So input numbers, and I'm just creating a list of a bunch of numbers. Okay, great. That's my list. Now I'm going to define a sort of dummy variable that we're going to store the total in. It starts at 0. It'll get added to one by one until we've added all the numbers in this list up here to that total. And we'll print the total out, and that'll be the sum of all the numbers. We're going to do that with a for loop, for number in input numbers, total plus equals number. Okay, so what just happened? Well, we get our for loop syntax here. So for loop is sort of fancy flow control, code flow. Instead of running our code top to bottom, this line once, then this line once, then this line once, then this line once, then this line once. That's not what happens. This line gets run once, then this one gets run once, but these two lines get run lots of times. Specifically, they get run once for every item in this list. So this list is 1, 2, 3, 4, 5, 6, 7. It's 7 elements long. So this line right here in particular, or these two lines are going to get run 7 times before we're allowed to get to this line here. And that's why it's called a loop, because we're literally looping through these two lines several times. Each time, number is going to get a new value. The first time we run through these two lines, number is going to get assigned to the first element in the list, 1. The second time we run these two lines, number is going to be assigned to the second number in the list, then the third, then the fourth, fifth, sixth, and seventh. So number is going to be 1. 0 plus 1, total starts off as 0. 0 plus 1 is 1. So now total equals 1, number equals 1. But then number is going to become 4. Total is still 1. So 1 plus 4 is 5. Total is going to become 5. Then 5 is going to get 3 added to it. That'll be 8. 8 is going to get 3 added to it. Then 7, 5, and 4 until we have the total. When we run this, if you check by hand, you'll see that the sum of all these numbers is 57. Okay, great, it works, fine, but I feel like it didn't really help you very much. Like I told you what happened, but you couldn't see it. You kind of had to take it on faith that number really was all those things in the process. And, we could open that up a little bit. I could just print number out before we add it. What am I going to get? I'm going to get every element in the list. 1, 4, 3, 33, 7, 5, and 4. See? And then I get 57 here at the bottom because this last print line runs. So maybe that's like elucidating, but really I'm just repeating what's in the list. So okay, maybe I could open it up this other way. I could just print total. What this does is it shows you total growing from 0 to 1 to 1 plus 4 to 1 plus 4 plus 3 and on and on and on. And you'll see it. Total starts at 0, then it grows until it hits the end of the list and becomes 57. So we're kind of getting closer to being able to see the code, and you're allowed to do this. You're allowed to print stuff, just add lines that say print whatever in the middle of the code to kind of get closer to seeing what's going on. But I want to provide you an even better tool for seeing all that. What I'm going to do, I'm going to copy this code. I've provided you a link to this tool that lets us visualize code execution or code flow in process, in action. So we paste the code in here, then we visualize execution. And we're taken to this screen. What you want to know, all you want to hit is next, and you want to watch this red arrow. The red arrow is where the code is right now. We're going to run the code line by line. I'm going to hit next. And input numbers is going to show up here as something that just got defined with what value. This is our representation of the list. You can see all the addresses of all the elements of that list. Okay, now the second line is going to run, and what I should expect to see here is below input numbers, one variable, we're going to get a new variable, total, And over here on objects is the thing assigned to total, which should be 0. And there it is. Total gets assigned to 0. Not in objects, but as its own in here, in there. Okay, great. Now what I should expect here, number is a variable. Number is a placeholder variable that gets assigned a value. It gets assigned specifically the value of the first thing in input numbers, which is 1. So when I run this, I should see numbers show up in the third line with the value 1. And there it is. Then what happens next? Total has already been defined. It should get incremented by the value of number. 0 plus 1 is 1. So when I run this, total should become 1. And there it is. Then when I run this, number should become the next item in the list. It should go from being 1 to being 4. Total should get incremented. Number should go from being 4 to being 3. Then after that, it should go to being 33. So there's 3. Then when I run this, run the next 2 lines, it'll become 33, then 7, then 5, then 4. And meanwhile, total has been getting incremented. Total is going to get incremented to its final value, 53 plus 4, 57. Now, 4 we're back at 4. We've already been through every element of the list. Or the meaning of 4, like one way of translating 4 into English is to say for every element in this list. We've been through every element of this list. Python should recognize that. It should say that, oh, well, 4 was the last thing. So what's going to happen when I run this is it's going to now skip the inner line and go to the final line. We finally broke that loop. We made it through all iterations of the loop. And now we get to resume the sort of standard top-to-bottom code execution. We're going to run this line, print total. This is going to be our output screen right here. So if total is 57, we should see the number 57 in the output. We do. And then the code ends. The code's over. That code ran. I can show you a slightly more complex example. Not too much more complex. I'm just going to add a variable called... instead of getting the sum of all the numbers, I want the sum of all the squares. So I'm going to multiply number by itself, assign that to a variable called square. And instead of adding all the numbers, I'm going to add all the squares. A square. Okay, so, and then total should print out the sum of squares. So once again, visualize execution. And we're just going to run it through. Input numbers will get defined. Total will get defined. Number will get defined. A square will get defined. 1 times 1 is 1. Total will become 0 plus 1. Then, now what's going to happen? We've made it through our first iteration of the list. So now number is going to become the second element of the list. It'll become 4. A square will become 16. Total will become 16 plus 1 is 17. Great. We'll do this for every element of the list. Total's growing quickly because squares are big, especially the square of 33. So now we're at the last element of the list. Number was 4 again. It's 4 a second time, which made a square 16, which is going to make total. Total is going to get 1189 plus 16 is whatever, is 1205. Now we've made it through all elements of the list. 4 is going to recognize it's been through every element of the list once. It's going to break the loop and continue on to the print statement. We're going to print out the sum of all the squares of all these numbers is 1205. Shows up right here. So you survived. We got to visualize code flow, and you can use this. Don't use this for like code that goes to the internet, my more complicated code like in the demos. But any of the simple, really simple illustrations of like this, here's a little like really closed 5-line example of a for loop in action or an if statement in action or any of these, you can paste in here and kind of run it. And you'll be showed line by line what's the entire state of the program. At every line, for every kind of loop, what is the value of every variable. That's really useful to get close to the code, to see code in action. It's useful for for loops, which can be really hard to visualize. It's useful for if statements which help you like skip lines of code. When you visualize if statements, you get to watch the code really jumping around. It's useful for functions when we get to functions, which are kind of down the line. It's even useful, like even standard kind of simple top-down code execution with no like indenting can be confusing, and this tool can help you understand that whole process as you go down. So any code you want to that you're having trouble like simulating in your head or playing along in your head with what the computer's doing, you can use this tool, paste your code in, run it through to really see things in action. Especially the simpler examples. So I hope you find this useful. I hope you find it useful being able to visualize code as you get better and better at playing code in your own head and simulating the computer in your own mind. This is a great tool, and I highly recommend it. You'll be the envy of other friends of yours who are learning the code who have never been exposed to this.